Hi everyone in Algebra 2B. Today we're going to be going over lesson 109. And this is more on the power or more on expanding. And something that you need to note is that the power rule cannot be used when we have a sum in the parentheses. So if you see something like x squared plus y squared to the power of 2, it does not just equal x to the fourth, y to the fourth. You can't just distribute that 2 to the exponent. But what you actually have to do is expand it like this. Okay. So what I'm going to do is I'm going to go through the examples. The first one is going to look similar to something you've seen before. So I'm just going to distribute the 3 to the exponents. And that would give me 2 to the third, x to the 3 halves, y to the 3 fourths, and z to the third. And then your result will just be whatever 2 to the third is, which is 8. And then x to the 3 over 2, y to the 3 over 4, and then z to the third. And that would be your result for that one. So expanding works the same for that one, just you want to make sure you actually multiply out your whole number. Now looking at 109.2, so this is similar to that example that I just showed you. So what you actually need to do is multiply out both of these. So it would be x to the 1/2 plus y to the 1/2 times x to the 1/2 plus y to the 1/2. And then you're going to multiply this through. So x to the 1/2 times x to the 1/2, I'm going to do it down here, would be 1/2 plus 1/2 equals a whole. Then x to the 1/2, y to the 1/2. Then my middle terms would be x to the 1/2, y to the 1/2. And then again, y to the 1/2 times y to the 1/2. You add exponents when you're distributing. So 1/2 plus 1/2 would be 1 whole, meaning that I can just combine these two middle terms because they have the exact same exponents. So I have x plus 2, x to the 1/2, y to the 1/2, and then plus y. So you distribute, simplify, and that's it. Now we're going to look at 109.3. So for this one, I also need to multiply this out fully. So I just need to do x to the 1/2 plus y to the negative 1/2 times exactly the same x to the 1/2 plus y to the negative 1/2, and distribute. Remember, when you're multiplying your bases, you add the exponent. So again, x to the 1/2 times x to the 1/2 would just be x to the 1, because 1/2 plus 1/2 equals a whole. Then I have x to the 1/2, y to the negative 1/2. My middle terms, again, x to the 1/2, y to the negative 1/2. And then y to the negative half plus y to the negative half. Negative half plus a negative half would be a negative whole. Again, you should see that your middle terms are going to be the same, so you can add those together. So I end up with x plus 2x to the 1/2, y to the negative 1/2, plus y to the negative 1. So remember, a negative half plus a negative half equals a negative 1. And that is all. Now, these are the problems that I want you to attempt before actually pressing play and doing the problems with me to make sure you did them right. So this is lesson 109, numbers 1, 2, 6, 7, 8, 9, and 10. So pause the video, attempt those problems before pressing play. Number 1, we have a 2-digit counting number, has a value of 8 times a number, 8 times the sum of the digits. If 6 times a units digit is 5 more than the tens digit, what is the number? So this one, we're not going to use any formulas that we have from lesson 107, but it says the value of a two-digit counting number has a value that is 8 times the sum of the digits. So that is going to be the original number, actually. So that's going to be 10t plus u. 10t plus u is going to be equal to 8 times the sum of its digits. So 8 times tens plus units. Then it says 6 times a unit's digit. So 6u is 5 more than the tens digit. So t plus 5. Now what I'm going to do is I'm going to distribute this and simplify. So that would be 10t plus u equals 8t plus 8u. So if I bring the 8t to the left, bring the u to the right, I'm going to get 2t equals 7u. Now if I solve for t in this equation, I'm going to get t is equal to 6u minus 5. So I have 2 times 6u minus 5 equals 7u. So distribute that. Get 12u minus 10 equals 7u. So when I bring the 7u to the left, bring the 10 to the right, I would end up with 5u is equal to 10. So therefore u is going to be equal to 2. Then to solve for t, I have t equals 6 times 2 minus 5. So that'd be 12 minus 5. So t is going to be equal to 7. So my answer, what is the original number? If the tens digit is 7 and the units digit is 2, my answer is going to be just 72. Now for the next one, we have the sum of the digits of a two-digit counting number was 11. So that's just taking the tens and the units digit and adding them together, you get 11. Then we need to refer back to lesson 107, our notes in 107, because it says if the digits reverse the new number. So the new number equation is right here. It's 10u plus t, reversed our new number. So what we want to do is we're going to do 10u plus t. The new number is 27 less than the original number. So the original number is 10t plus u minus 27. And now we're just going to solve. So this is from lesson 107, the notes from lesson 107. So now what I'm going to do is I'm going to move the t to the left. So minus 10t, bring the u to the left, minus u. So I have negative 9t plus 9u equals negative 27. If I multiply this by 9, I would get 9t plus 9u equals 99. So I'm doing elimination. I would get 18u is equal to 99 minus 27, which is 72. And then I can divide by 18, so I get u is equal to 4. Now I know what u is equal to. I can plug it into the top equation, so it'd be t plus 4 equals 11. So my t is going to be equal to 7, and for this one they want to know what the original number is. So if the tens is 7 and the units is 4, the answer will be 74. Will be the original number. Okay, so you should have attempted those before actually getting an answer. And now we're going to look at numbers 6, 7, and 8, all of which are problems from this lesson. So I'm going to start by distributing the 3 to the exponent. So that would be 3 to the 3, x to the 3 over 4, y to the 3 over 2, and then m to the third. And then my answer is just going to be what's 3 to the third, which is 27, x to the 3 over 4, y to the 3 over 2, and m to the third. And that's your answer. But looking at number 7, we actually need to multiply out this whole thing. So really you have x to the 1/4 plus y to the 1/4 times the same thing, so 1/4 plus y to the 1/4. When you distribute, you're going to add the exponent. So 1/4 plus 1/4 would be 2/4, which would be equal to 1/2. Now I have x to the 1/4, y to the 1/4. My two middle terms would be x to the 1/4, y to the 1/4, and then y to the 1/4 plus y to the 1/4 again would be y to the 2/4, which is 1/2. Now lastly, you just want to combine your two middle terms. So your result is going to be x to the 1/2 plus 2x to the 1/4, y to the 1/4 plus y to the 1/2. Looking at number 8 should be pretty similar to the last one. So I'm going to just expand this. It would be x to the 1/4 plus y to the negative 1/4 times x to the 1/4 plus y to the negative 1/4. When I multiply x to the 1/4 times x to the 1/4, you add the exponents. So 1/4 plus 1/4 would be 2/4, which would equal 1/2. Then first term times last term would be x to the 1/4, y to the negative 1/4. Middle term, x to the 1/4, y to the negative 1/4. And then y to the negative 1/4, y to the negative 1/4 would be y to the negative 1/2. And then we add the two middle terms. So your answer should be x to the 1/2 plus 2x to the 1/4, y to the negative 1/4 plus y to the negative 1/2. So when you're multiplying bases that are the same, you add the exponents together. That's why we got the 1/2 and the negative 1/2. Now for number 9. So number 9, we have to refer back to our lesson 108, which has these two equations and then our steps that we're going to follow. So for the first one, we are going to use this equation here because it has a minus sign in between the terms. So really I have f cubed minus s cubed equals f minus s times f squared plus f times s plus s squared. And that's what you get. We're going to start by taking the cubed root of the first term and the second term and then plugging it into the equation. So I have the cubed root of x cubed y to the 6th and then the cubed root of 27m to the 3rd. So you just divide the exponents by 3. That's how you find the cubed root. So 3 divided by 3 is 1. 6 divided by 3 is 2. So that's my this is going to be my f. And then 27, the cubed root of 27 is 3. And then 3 divided by 3 is 3. Or is 1, sorry, I'm to 1. Now this is going to be my s, and I'm going to plug it into that equation. So I have xy squared minus 3m times xy squared squared plus xy squared times 3m, and then plus, 3m squared. And all you need to do now is just simplify that. So the left parenthesis stays the same at xy squared minus 3m. I'm going to square the x is x squared. I'm squaring the y squared, which is y to the 4th. Then plus 3m xy squared. And then 3 squared is 9. And m squared is just m squared. So this whole thing right here is your answer. So if you forget how to do that problem, I would refer back to your notes in lesson 108. And then lastly, we're going to look at number 10, which is a similar problem to this last one. So what you need to do is take those notes back out. And then I'm going to write down the equation that we're going to use, which is the top one because of the plus sign. And that's going to be f cubed plus s cubed equals f plus s times f squared minus f times s plus s squared. Now we're going to take the cubed root of both of the terms. So cubed root is 64 x to the 9th, y to the 6th. And then the cubed root of p to the 12th, z to the 3rd. Now when I take the cubed root of 64, I'm going to use my calculator. So I'm going to 64 second y to the x3. So that is 4, because 4 cubed is 64. Then for our exponents, you just divide it by 3. So that would be x to the 3rd, y to the 2nd. Divide 12 by 3 would be p to the 4th. Divide 3 by 3 would be 1. So this is going to be your f. This is going to be your s, and you're going to plug it in. So I have 4x cubed y squared plus p to the 4th z times 4x to the 3rd y squared squared minus 4x to the 3rd y squared times p to the 4th z plus p to the 4th z squared. The left parenthesis is going to stay as is, so it's 4x cubed y squared plus p to the 4th z. Then I'm going to have 16 x to the 6th, y to the 4th, minus 4 x to the 3rd, y to the 2nd, p to the 4th, z, plus p to the 8th, z squared. So all I did was distribute the power. And that is your answer for number 10. So I hope that got you started on your lesson 109. And then you need to post your questions for 109A by tomorrow at 9 a.m. Have a great day.